Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly.
Hello everyone and welcome to the webinar. My name is Kevin Gaunt and I shall be the moderator for this webinar. The webinar is entitled Making Motor Management Smart Can Be Key to Increasing Your Plant's Productivity and Efficiency, and it'll be presented by Paul Pryor from Schneider Electric. There will be a short time for questions and answers at the end of the presentation. But please note the presenter's details, which will be shown during the Q&A session, should you wish to contact them for further information. Please post any questions you have using the Q&A button in Microsoft Teams. Details of the next webinars will be shown at the end of this session. So thank you, and I would now like to hand over to Paul. So Paul, if you could unmute your mic and share your screen, please.
Good afternoon. Thank you very much, Kevin. As Kevin has spoken, I'm going to be talking about making motor management smart and understanding its benefits when you come to plant productivity and efficiency. So when we look at the major concerns that are facing the water industry, you can see we've highlighted some areas where we see that problematic within inside the water industry. They're facing a number of growing business and economic challenges, the cost of water being one of them. Electricity equals a third the cost of the water, so electricity costs going up are impacting your overall revenue streams. The losses or non-revenue water as well, having problematic systems where the higher the water losses, then obviously the losses within inside your business is higher. Wastewater processing costs are going up as you have to meet higher and higher demands and specifications within inside the quality of the water, and more legislation coming out that drive the business and the costs of the business to comply to. We talk about ISO 50001, the effective energy management being one of them. And then when we look at sort of things like the maximising the assets, you're obviously now dealing with an ageing infrastructure. Your assets are trying to do more for less, as it were. You're getting smaller duration and contract. And as we talked about, again, new legislation coming in, not just around the energy management, but also around the asset management capabilities of the system. And all of this to maintain a 24-hour delivery. You have to maintain through all of the types of installations that you have. You have to ensure the protection of your assets in proper health, and then obviously you have to understand the measures that you're being measured to, and more understanding how that impacts you. So all of this is now the major concerns driving into the major challenge, and all of those things that we talk about there in the previous slide are really driving you to understand that there is more investment requirements. But at the end of the day, companies facing major challenges to free up or obtain the cash necessary to first implement an upgrade strategy with aging assets, but also looking at the expenditure of new assets if necessary to be able to meet the future demands going forward from the government. And the life cycle on the right hand side shows some of the things that you have to carry out, some of the stages you have to carry out to be able to to justify and obtain funding from agencies and governments. So all in all, quite difficult to free up the cash to invest in your business, to upgrade it through the normal means. But so what we're looking at here to understand is digital technologies that are giving you the opportunities to utilize what you have better, to be able to cover the business challenges that you see. So we're talking about commodity prices, generation shifts, capex, opex, immediate return on investment, obviously from a business perspective. There's the aging infrastructure, and there's the market regulations that we're changing. So how do digital opportunities help you to unravel some of those problems? So we've spoken about the challenges that the industry faces in the previous slides. So let's look at the digitalized opportunities. So the different phases of your business. You have the design phase, where implementation of things like digital twin methods can help improve the design quality and reduce build times and installation times and reduce setup costs. During the operation and maintenance phases, the IoT, which brings the IT layers and the OT layers together, leading to access to the big data packets from your plant and process. And this starts you on the path of utilizing cloud-based technology for analytics, analytical analysis of your plant data, and use for asset monitoring, preventative maintenance scheduling, basic event notification. And then if we take that a step further, it also leads into the machine learning cycle through AIs in cloud-based services that allow you to then step into things like predictive and notification of events, so predicting and notifying of events before they become a process interruption event. And the next generation of working through augmented or virtual reality techniques to enhance the operational maintenance processes and procedures with real-time information, instructional step-by-step guides, and allows safe operation of possible dangerous plant operation, i.e., for example, turning an MV switch back on after a fault can always be a bit of a worry. So with augmented operator or augmented reality, you have the ability to be able to operate those from a safe environment behind closed doors. So if we notice, we showed the workforce generational shift as a business challenge. It can also be looking at as a positive. When you talk about the new generation of engineers being smart, savvy, they're already brought up with these smart devices, and so the adoption of new technology is eliminated or reduced, drastically reduced. We'll see the increase in benefit of the digital servicing information to an engineer on the plant or on the machine through smart devices, allowing immediate reaction to events and reducing time to fix and increasing OEE. We'll discuss OEE a bit later on. We've spoken earlier about how the access to the machine big data through IoT helps you understand your plant at a digital level and optimize your asset usage by identifying and, if requested, selecting best efficiency asset usage to match your energy and your delivery needs through the agile operation process set up and refined over time. All the above is made easy with the integration of digitized products, where the products themselves acquire, log, and make the big data available to be used. E.g., for example, where is it better placed to understand the performance of a pump than the VSD that controls the pump? That VSD can log that information and it can be utilized. So let's see how we in Schneider Electric use EcoStruxure as the methodology to achieve the best results. And on the right hand side, we talk about EcoStruxure plant. And what I'm going to speak about now is some of those 4 steps that we see how taking a digital grasp of the situation will give us that ability to enhance your performance. And as you can see here, efficiency and profitability, reduce costs, increase productivity, safety and security, reliability and performance, and then sustainable and transformation. And we'll talk about some of those as we go through. Some of the big losses that you see here: downtime, minor stops, production rejects, in terms of changeovers. You can have different changeover aspects, delaying times, reduced speeds, and obviously rejects. And this all leads to the OEE overall equipment efficiency figures. And more now people are taking this OEE figure and utilizing it to benchmark their products or their machines and their processes against other processes to understand where they can best gain performance and reduce costs by implementing similar operational techniques across multiple sites. Typically, OEE is made up of 3 figures: the availability figure, the performance figure, and the quality. And small changes in each of those can drastically change your overall equipment efficiency figures. When we look at the sort of transition of motor control over the period of the last 20 years, you can see that we've gone from traditional DOL starting, if you like, where the pump is mechanically controlled, the valve controls the flow, through to the VSD controlling the flow, but then upstream standard IO devices controlling it, to a service-orientated system where now communications between the pump, the drive, the monitoring system, and cloud-based services give you access into real-time profitability, energy efficiency, and asset performance. And this is really showing you how the cloud-based services that we talk about can enhance and are connected through either agnostic data collectors or through proprietary PLC collectors, and then that information between the OT and the IT layer is utilized for cloud-based digital services, web services, or even proprietary SCADA stroke systems that monitor your processes in line. So one of the ways that we've sort of introduced our technology or enhanced our technology inside Schneider Electric is making motor management smarter, all the way from the basic DOL starter all the way up to a VSD. And this is a new product which shows the benefits of having motor starters as an island linked together through communications and utilizing them to gain data, to utilize data and make that available upstream. So those are digital contactors Power is controlled through the normal style of contactor, but built inside them are printed circuit boards, which basically are monitoring the device, giving you healthy information, giving you status information, performance information, and then feeding that up through to your mid-layer PLC, which is basically then utilizing that information. And the same with the drives. The drives follow that principle of IoT ready, where they are now storing the data, monitoring the data, operating the machine, understanding the machine, and then making that information available upstream to be able to be utilized by the apps and analytics levels, where we can now do things, preventative maintenance scheduling, active messaging, to enable us to be able to work closer with the plant and more efficiently with the plant and the process. So when we look at this and the next step, and we want to see, well, how can we utilize this information that we're generating? Obviously, we can go through this consulting firm type, and then put this consulting firm type methodology up there. But obviously, that can take a long time. You know, on average, 18 months for the first results. It's very internal resource intensive, and it can be very expensive. So what's the alternative to this? The alternative is to using some form of AI advisor suite. And that gives us the ability to be able to take that information from the devices themselves. It allows us then to be able to utilize that information at a base level to tackle operating expenditure like energy and maintenance costs, operational costs. It provides management capability of baseline trends, layers of improvement, potential savings, follow-up. So it's permanently learning the process, and it was giving feedback all the time. Not just from an operational level, but also from an OEE level, and then obviously achieving the objectives, identifying the targets, providing recommendations, and then delivering implementation guides. So through the life cycle of your product, it will monitor the information that's going on. It will continue to learn from what's happening with your system, and it will make recommendations based on what it sees and how it reacts. And then what does that give you? That gives you obviously the control. It gives you the information that you want. It gives you the operation that you want through your PLC, your motor starter. It's all logged through an agnostic system up into the cloud-based system. But then your staff has access to web serving online information, but also direct control through email and texts directly to them on alarms and status changes. So it's permanently monitoring your system. And permanently updating your staff through a web server or through alarms and alerts, which can come through text and through email systems. So it's a multi-site for benchmarking. It's a good way to understand how the systems work together and how they are effective, but also how they compare against each site. So you're now in effect creating that ability to be able to monitor what different sites are doing with similar assets and understanding how they're performing, and then obviously doing something about it. So what we end up here is we end up with the view of what sort of information that you'll be getting back from the pumping performance advisor, reducing the three major components of the total cost of ownership, the energy costs, the maintenance costs and the operating costs, having full visibility of how your system is working, where its percentage energy consumption is, where its downtime is. So knowledge is key here. So from understanding what type of application you're utilizing, what type of functionality you're putting inside the system, and understanding the impact on those to give us this life cycle understanding through the total cost of ownership for that particular pumping set, and then driving yearly cost savings through as you can see, through energy cost savings, maintenance cost savings, and operational cost savings. So in energy, we're avoiding areas of inefficiency. We can learn and in effect utilize the correct, most efficient pump at the most efficient time based on your energy costs. We can switch in and switch out as necessary devices depending on flow. We can report back on maintenance costs, which will give you information about how long the product's been running, what the digital content is in terms of temperatures, monitoring the temperatures. If it's been over temperature for a period of time, then obviously we can affect what the life cycle is of the system. And then operational costs relating to insight and KPIs, the alarming, the real-time information, which gives you then benefit to be able to make decisions based on those real-time and data provided information. All of this is as I've talked about, is agnostic. The choice in this case predominantly is driving down the VSD route, which is obviously the most efficient route where you come to energy efficiency of big pumps. But with the knowledge that utilizing something like TSIS Island, which I spoke about, which is a digital DOL, it gives you that ability to also start tapping into those digital advances, even on DOL starters. So that gives you the ability then to pull that information into a cloud-based service and enable you to then work and operate and understand how the best way to run your plant and what the best way is to save energy, how best way to reduce maintenance costs, and obviously maintaining your operational costs. At the end of the day, pumping cloud-based advisors are driving more and more the way that we do business, with their artificial intelligence enabling the system to understand and learn from itself. Gives great advantages of being able to look at individual pump sets and also be able to compare pump sets against other pump sets and how they operate together. So when we look at the EcoStruxure plant in its entirety, and this can really be shown for any type of system really, where we're looking at what we call connected products. These are the smart devices, the smart starters, the smart VSDs, and then the edge control can be your existing PLC, or it can be retrofitted PLCs, or it could be agnostic IoT boxes, which are purely there to pull the data, concentrate the data, and then make it available either through networking or through 3G or 4G or wireless. And then at the top end you have full performance software performance systems, from asset advisors through to profit advisors, maintenance advisors, and pumping advisors. On top of this type of once that information is fed up through the connected layer to the edge control, you also bring in the level of augmented reality and virtual reality concepts, which then gives you the ability, as I spoke before, about being able to understand and operate your system through live data, through step-by-step guides, through safety information and safe switching of hazardous products. So that's what we in terms of the architecture that we look at. And as I said, smart motor management is the core of this, where understanding that a large proportion of the energy that you use goes towards turning pumps. How you control them is important, how that information is used is important, and how that information is fed back to the operators is important. And that's why this 3-layer stack is the way that fits to all of those levels of discussion and all those levels of performance. So that's myself. I've gone through pretty much everything I wanted to discuss. So we're at a point now where we can open that up for some questions.
Okay, thanks, Paul. I have a couple of questions here for you, just to kick us off. First one, if I'll read this out to you: what is the best way to upgrade an older traditional motor management process to a new smart motor management process?
Yeah, good question. One of the things to remember here is that when we talk about upgrading from traditional to smart, everybody initially is balked at the idea of having to rip out all of their equipment and then replace it with smart equipment. That's not necessarily how you have to do things. You from a new plant perspective, of course, you would go down the route of smart devices being from the beginning. But when you're looking at retrofitting, the good thing about the type of systems that we have is that you can fit the digital side of motor management onto existing motor management systems. It doesn't take a lot. It just takes the ability to be able to data concentrate the information that's already there, make it available, and then feed into our cloud-based service or a cloud-based service where that will automatically then utilize that data and obviously give you reports and access to the information that we want. So the good thing about talking about upgrading is that you can take it step by step. You can take asset by asset or station by station as fast as you want to go, and you will get the benefits almost immediately from opening up your starters to the digital world.
Brilliant. Okay, thanks for that. Another question, quite a straightforward question. May not be a straightforward answer, but we'll find out. Do I need to change my PLC or amend my PLC software to incorporate smart devices?
Yeah, that is one of the questions where I get asked a lot, because obviously now what you're looking at doing is you're looking at trying to understand how you get that data out. You can obviously feed that through the PLC, and the PLC is in a prime position to be able to collect that information. But as the person says, that is a requirement of then changing some software to be able to write a program to pull that data out. You don't have to touch your PLC, you don't have to touch your software. The agnostic IoT box, as I've said before, is a data collector on its own. It sits totally agnostic, totally separate from the system. All it does is sit there collecting data from your assets. Once it collects the data and it pulls them together, it then shares them to whatever system you want upstream to enable you to do your apps analytics completely independent of what the process is doing, and no changing of what the PLC does.
Brilliant. Okay. Another question. What do you see as the main barriers to the provision of smart devices within the water industry?
Yeah, so the one thing to remember here is that smart devices are there not only to control the device, of course, that's the traditional way that they do it, but also start to produce data. Now, you have to do something with that data. There was some information which was a time and motion study, or a study which came out, which showed that of all the data that's been generated at the moment, 97% of the data generated is not being used. And the reason for that is because traditionally, if you wanted to go and see what the energy usage was on your machine, you would send a man down who would go down there, he would have a clipboard or his PC or whatever, and he would take some readings, you would do a study and you come back. Now you imagine timesing that by 1 million. You're getting 1 million pieces of information an hour a day on all the assets that you have. The first problem you have is that you don't have the people to be able to manipulate that data because there's so much of it, and you can't make decisions because you don't have the data analyzed. So the biggest area for me moving to a digital world is what you do with the data. We can generate the data, but you have to have a proviso within your system, within your processes, within your employees, if you like, to be able to analyze that data and then make decisions on that data. And that's where cloud-based AI services come into their own, because they can monitor and manage millions of pieces of data a day and still come up with correct information, timely information, and respond to immediate activities.
Brilliant. I mean, in a sense, you need to almost adjust your organisation to be able to cope or to make best use of the additional data that's now available, don't you? So it's almost about doing things in a different way. So I suppose one question I'd ask: have you got any case studies of where you've seen organisations have really taken that on board and managed to leverage the opportunities that these sorts of smart devices make available? Yeah, more and more now, you know, the big companies that we deal with are globally are taking that on board. They are doing, whether it's machine level or plant level, they are starting to implement these types of digital techniques. And it could be as simple as just monitoring the machines on their process line to ensure that each machine is optimized for the energy used. One of the biggest things that people see but talk about now is obviously the cost of energy. And if I can reduce my cost of energy just by monitoring and making sure that it turns off when nobody's in during production, it turns off, and during non-production time it turns off and isn't left on dormant, running, wasting energy, then straight away that energy is money that you're saving there is straight back into your coffers. So we are seeing lots of our companies picking this up, and we do have case studies where this has happened around the world. Excellent. Okay, well, I think we're about there now then, Paul. So can I thank you for the presentation and thank everybody for attending. The next two sessions are shown on the next slide. But just before I move on to that, if you do have any more questions for Paul, as it says on this side, please visit the exhibition stand, and I'm sure Paul and his colleagues will be more than happy to help you out with that. So thank you everyone, and goodbye for now.